Hi everyone. Our topic for mechanics of deformable bodies is about shear force and bending moment. So, the intended learning outcome of this discussion is that at the end of it, the student will be able to define and explain shear and moment diagram. The student will be able to use techniques in establishing shear and moment diagram. And finally, the student will be able to solve problems in composite beams. So the outline of the presentation is as follows. So first we have introduction, then the types of beam and load. Therefore, we will discuss what type of support the beam have and the reactions of that particular support. Then the shear force and bending moment, its definition and application. And finally, the relationship between shear force and bending moment. So for the introduction, um, shear force and bending moment is devoted to the analysis and the design of beams. Beams are very important in almost all structures visible to the naked eye. For example, you see the building, even your house is made up of beams. So the beams are structural members nga horizontal siya. So ang vertical is column while those horizontal structures are beam. So they are usually long, straight, prismatic members. Pasabot, the cross-section of the entire beam is uniform. From one point to another, it's prismatic, it's uniform. It can either be um, rectangular, circular, or I-beams. In most cases, load are perpendicular to the axis of the beam. So if you have a horizontal beam, then your load applied is vertical. It is perpendicular to the beam. So transverse loading causes only bending, and we will signify this as M, and shear V in the beam. Shear is symbolized as V. Let's put into mind that when we analyze beams, we have to neglect the weight of the beam. But in reality, you cannot neglect the weight of the beam. But for simplicity's sake, to simplify things, and this is just an introductory part, and so we will just neglect the weight of the beam itself. So types of load and beams. So the transverse load of beam may consist of concentrated load. This load P, P1. Usually concentrated loads are um, symbolized by P1, P2, and this is applied at a particular point in the beam. So this unit, the unit of concentrated loads is always can always be Newton, and distributed loads W. So this is an example of a distributed load. So you can have a uniformly distributed load, or this one, rectangular distributed load. So the reaction, we will discuss the support. Support A is, what is this? Are you familiar with the type of support? Nga pwede ikuan sa beam. So we can have roller, pin, and fixed support. So this one is a pin. So in a pin support, we have two reactions along Y and along X. And this roller, because it can move along the X direction, so walay support along X. Therefore, ang naara siya is ang along Y. So this is a roller and this is a pin. And the distributed load can be Newton per meter. So variation only. Types of load and beam. So there are two types of beam actually. Statistically determinate and statistically indeterminate beams. So this simply supported beam, how many reactions ang naaaning nga beam? So you have two for pin and one for roller, so three. But you can see that um, the loads applied in the beam are more or less vertical to the perpendicular to the beam. So we can always assume that the reaction of pin A F reaction along X is 0. So and if you sum the moment at point B, assuming this is point B, if this is point A and this is point B. So if you sum the moments at point B, then you will get the value of the reaction at point A, because reaction at point A multiplied by the length of the beam, you will get the reaction of this, and that is equal to 0. So this is a simply supported beam. So both ends have simply supported. So it has a roller and a pin. And this one is an overhanging beam. So naa siya'y overhang. The support, the pin, or the roller support is not at the end. It's in the middle of the length of the beam. And this is a cantilever beam. A cantilever beam is at one point, at one end of the beam, it is supported, it is fixed supported. So we have, when you say fixed support, you have reaction along Y here, reaction along Y. You have reaction along X, and of course you have the moment here. That is a fixed support, and it is cantilever because one end of the beam is not supported. And this is a continuous beam. So you have um, three supports. For example, actually a continuous beam can have as many support as it can. So kani siya, simple lang ni siya nga continuous beam nga three supports lang. And then this one is a fixed beam at one end and simply supported at the other end. So this beam is fixed beam. Pasabot, both ends of the beam is fixed. So how many unknowns here? You have 1, 2, 3. So the same goes at this end. You have here, because it's simply supported, it's fixed supported. So the both ends have 3 unknowns. So muna siya. Okay? So with this type of beam, we'll not discuss it here because it's for more or less part of the specialization of civil engineering. So we will focus our attention to simply supported beams, and we can have cantilever beam, but of obviously we will focus our discussion on statistically determinate beams, because lahat na po ang procedure when you are dealing with indeterminate beams. Okay? Our next topic is the determination of maximum stress felt by the beam. So we have formulas here for easier references, and if you want to derive this equation, kung ahani siya gikan, you are very much welcome, and you can find that in our textbook. So for easier access, then you have to familiarize this formula. Maximum stress is equal to mc over I, where m is your moment and I is your moment of inertia. But in shear and moment problems, sometimes the section modulus is given. So the maximum stress is equal to moment over the section modulus. And this is the formula over section modulus. S is equals to 1 over 6 ph squared Then for your moment of inertia, I is equals to 1 over 12 BH cube. But take note, these equations is for a rectangular cross-section. How about if we have square, or if we have circular, or we have a regular shape na cross-sectional area of the beam? For example, we have I-beam, we have H-beam. So, hindi mo siya pwede gamitin yung formula. And that is why we have these formulas. Take note that for the rectangle here, you have your this equation. Diba? I is equals to 1 over 12 BH cube. If you translate, or if you get the moment of inertia along the x-axis, then you have along this the midpoint, and you have moment of inertia at y prime here. Mo po ni siya 1 over 12 BH cube H. So just take note that the analysis, the common analysis of shear and moment diagram is that we focus on rectangular cross-sectional areas of the beam. And if not, then we will go back to these equations, because you cannot directly use the formula given, because you have to consider first the rectangular. Otherwise, if it is stated in the problem, then use that equation kung sa gihatag sa problem. So, shear and bending moment diagrams. Shear force diagram, or let's call it SF diagram. It is the shear force. It is the shear force plotted against the distance measured from the end of the beam. So, this is a shear force diagram. So, this is the value of the shear force at a particular distance from this point. Let's say this is point A, and this is point B. So, it is just a plot of shear force at any particular distance from the one end of the beam. Then, bending moment diagram, or BM diagram, is this one. It is the bending moment plotted against the distance measured from the end of the beam. So these values here are the value of the bending moment at a particular section of the beam. For example, at 2.4 meter from point A, so the value of the shear force is negative 108 kilonewtons. So this one. And at the same distance, at 2.4 meter from point A, the value of the moment is, the bending moment is negative 129.6 kilonewton meter. So at this exact point. So this is one of the importance of having a correct shear and bending moment diagrams, because you don't have to solve each section. You only have to look at the graph diagram, and you will be able to give the correct shear force and bending moment at any points in the beam. Okay? So, determination of shear force and bending moments. The shear and bending moment diagram will be obtained by determining the values of V. V is your shear, and M at selected points of the beam. So, first thing you need to do is to select what sections we're going to shear, to slice imong tunga-tungaon. So, consider this beam. You have point A, it is simply supported beam. At A, it is spin. So, you have how many reactions? You have 2 reactions, but your X reaction is 0. And for B, it is It is roller supported. So at this point, you have point C here. So at point C daw, diri daw kuno nimo siya pangitaon. You are tasked to find the shear and moment at point C. So what will you do is that you have to, unsa mo i-consider nimo? Kani siya nga portion or kani nga portion? Which is easier? Kung imo pa lang ng mata-matahon, of course, imo dyan makita nga easier ang B. Why? Because you only have to consider the point load P2, where in fact in this at the left side of the beam nakay concentrated load P1 and then you have a distributed load W. So but the before we select which section ang atong kuan, let's start analyzing the left side of the beam. So in this part, in this section, you have your action at A, and you have the load carried over. Then you have shear V and moment M. So, diba, this is a positive moment. This is positive moment and this is a positive shear. Our convention earlier, diba? Mano itong convention. Now, if we consider the right side of the beam, we have your reaction at B. So you have RB. And then you have concentrated load P2 here. And then you have V prime and M prime. And this convention is our positive, right? But take note, M is equal to M prime here. And your V at left side is equal to your V prime. So if you are tasked to evaluate or to get the value of shear and moment at point C, so asa man yung pilion? Obviously kani, di ba? It's easier. Right? Compared to dire, libog na ka napaka i-consider na concentrated load and distributed load. Okay? So let's continue. Determination of shearing force and bending moment. So the shear and bending moment at any given point of the beam are said to be positive when the internal forces and couples acting on each portion of the beam are directed as shown in this figure. Okay, take note ha, when you consider the left side of the beam, then the positive convention for shear is this one, going down. And the moment is in this direction. So, when we consider the right side of the beam, going up is positive and our moment is going here. So, that is our positive shear and positive bending moment. The shear at any given point of a beam is positive when the external forces, the load and reaction acting on that beam tends to shear off the beam at that point as indicated in the figure here. So, if you will consider this portion, then you have a reaction here. However, your shear at this particular point will be going down. So that is why our shear here is positive because it is our convention that this, to have it balanced, to have this section balance, dapat imong shear padulong dito because you have a reaction nga dinhi. And considering this section of the beam, your reaction is, your support is here, diba? Muna ang support nimo. So, kasabot ang imuhang shear is going up. Kasabot. So, that is why this shear is positive. Muni. Atong V prime. Positive dire. So, kani siyang V Mo po ning naa dinhi. Mo po ni siya. Okay? Simple ra kaayo. Don't confuse yourself. Don't complicate yourself. For the external, for the effect of external forces, positive bending moment. When the moment applied here makes the beam smile, then that moment is positive M prime. Okay? So when you consider this part of the beam and you have a moment here, then that is positive moment. And when you consider this part of the beam and that moment is M prime is positive. Simple na now.